A footbone. That's all it was. Buried in a cave in South Africa for almost 2 million years. Nobody expected it to hold a secret this dark. When researchers finally examined it under a microscope, they found something growing inside the bone itself. A tumor. Malignant. Aggressive. The kind of growth that spreads and kills. This bone belonged to a creature that walked the earth before humans even existed, before fire, before language, before tools as we know them. And it had cancer. If you're watching this from a quiet room right now, wondering how something so modern could reach back that far, you're not alone. Most of us grew up believing cancer was a disease of processed food, pollution, and modern stress, a punishment for the world we built. But the fossil record tells a different story, a far older, far stranger one. Drop a comment below and let me know where in the world you're watching from tonight. Because what you're about to hear rewrites everything we thought we knew about this disease and about ourselves. Let's dig in. Here's the assumption almost everyone carries. Cancer feels new. It feels like something we invented through bad habits, factory smoke, and sitting too long at desks. That assumption collapses the moment you look at the evidence. In 2016, a team of scientists studying that South African footbone confirmed their diagnosis. It came from a species classified as Paranthropus, or early Homo, dated to roughly 1.7 million years old. The growth wasn't a fracture or an old injury. It was osteosarcoma, a savage form of bone cancer that still kills people today. Nearby, the same research team found a second surprise, a benign spinal tumor sitting in a skeleton from that identical era. Two separate signs, two separate individuals, both pointing toward the same uncomfortable truth. Long before Homo sapiens existed, cancer was already writing itself into the bones of our ancestors. Scientists have a word for these growths: neoplasms. And finding neoplasms this deep in the fossil record forces a complete rethink. This isn't a disease that arrived with modern life. It's a disease baked into the biology of complex, multicellular creatures. But here's the catch, and it's a big one. Cancer usually strikes soft tissue first: organs, skin, blood. None of that survives the crushing weight of deep time. Soft tissue rots, decays, and vanishes within decades, sometimes years. What's left behind is bone. Hard, dense, stubborn bone that can survive for millions of years under the right conditions. So think about what that actually means. Every fossilized tumor we've discovered is only the tiniest fraction of the cancers that once existed. Researchers call this a preservation bias. We're not seeing the full picture. We're seeing only the fragments hard enough to outlast time itself, which raises an unsettling question. If bone alone tells us this much, what would soft tissue reveal if we could ever get our hands on it? As it turns out, in a handful of extraordinary cases, we actually can. That's where mummies come in. Unlike a fossilized bone, a mummified body sometimes preserves organs, muscle, and skin. Egypt's dry climate and deliberate embalming practices created something rare, a window into soft tissue disease from thousands of years ago. Using modern CT scanners and advanced imaging, researchers have scanned mummy after mummy searching for tumors. In one landmark study, scientists examined 137 mummies. Inside several of them, they found unmistakable evidence of cancer. If you're finding this as unsettling as I did, go ahead and hit subscribe, because the next part of this story gets even stranger. Bones and mummies together build a consistent, undeniable picture. Ancient people got cancer regularly. Not occasionally, not rarely, regularly. And it turns out they knew it. Long before microscopes or biopsies, ancient physicians were writing down what they saw. The Edwin Smith papyrus, an Egyptian medical text dating back roughly 3,600 years, describes bulging tumors of the breast in painfully clear terms. The author notes plainly that there was no treatment. Imagine being a physician nearly 4,000 years ago, staring at a disease you couldn't stop, and writing that failure down for history to find. Centuries later, around 400 BCE, the Greek physician Hippocrates studied tumors and noticed something strange about the swollen veins surrounding them. They reminded him of a crab's legs, reaching outward in every direction. He named the condition carcinos, the Greek word for crab. A Roman physician named Celsus later translated that word into Latin. Cancer. The same word we still use today, over 2,000 years later. Civilization after civilization, culture after culture, people kept encountering the same enemy. They gave it a name. They documented its horror. They just didn't understand what was actually causing it. To understand that, we need to go smaller, down to a single cell. Cancer begins with a mistake. A single cell divides, and somewhere in that process, its DNA gets copied incorrectly. Normally, the body catches these errors almost instantly. Built-in repair systems scan for damage and either fix it or destroy the faulty cell before it causes harm. But sometimes, a mutated cell slips through undetected. It starts dividing without control. It multiplies into a mass. Eventually, it pushes into surrounding tissue that was never meant to host it. Here's the part that changes everything. Mutations aren't rare accidents reserved for unlucky people. They happen constantly, every single time a cell divides. They're a built-in risk of simply being alive. The more cells an organism carries, and the longer that organism lives, the more chances exist for one of those mutations to slip past the body's defenses. This isn't unique to humans. Dinosaurs developed cancer. Ancient fish carried tumors. Even trees, standing silent for centuries, can grow cancerous masses inside their trunks. Any living thing built from dividing cells carries this same fundamental vulnerability. Which brings us to the real twist in this story. If mutations are constant and unavoidable, did our ancient ancestors actually escape cancer more often than we do today? The honest answer might surprise you. Yes, probably. But not for the reason most people assume. It has almost nothing to do with immunity, and everything to do with time. Most ancient humans simply didn't live long enough to develop cancer. Life expectancy for prehistoric humans hovered somewhere between 25 and 35 years. Infection, injury, predators, and famine claimed lives long before old age ever had the chance to. Cancer, on the other hand, is patient. Most cancers take decades to fully develop, often emerging after the age of 50. If a lion, a broken bone infection, or a bad harvest kills you at 30, cancer never gets the runway it needs. Ancient people also faced a different set of risks entirely. They weren't inhaling cigarette smoke or absorbing industrial chemicals. Their diets consisted almost entirely of whole, unprocessed food. Physical movement wasn't optional. It was survival. All of that reduced certain risks dramatically. But don't picture some cancer-free paradise. Smoke from cooking fires irritated lungs for hours every day. Parasites triggered chronic inflammation, a known driver of certain cancers. Unprotected sun exposure raised the risk of skin cancer with every passing season. Ancient humans weren't shielded from cancer. They were simply outrun by everything else trying to kill them first. Sit with that for a second. The disease was always there, lurking in the biology of every human who ever lived. It just rarely got the chance to finish what it started. So if cancer has always existed, why does it feel like a modern epidemic? Why do we hear about it constantly today, in ways ancient physicians never could have imagined? Part of the answer is simple. We live longer now. Modern medicine eliminated or reduced many of the threats that once killed people young. Infections that once meant a death sentence are treated with antibiotics. Injuries that once proved fatal are now survivable. As a result, millions of people now reach their 60s, 70s, and 80s, exactly the age range where cancer has the time it needs to develop. Detection changed everything too. Ancient physicians could only diagnose what they could see or feel through skin. Today, imaging technology can locate a tumor the size of a fingernail buried deep inside the body. We're not necessarily getting more cancer than our ancestors. We're catching far more of what was always quietly there. And yes, modern life introduced genuine new risks on top of that. Tobacco use is directly linked to lung, throat, and mouth cancers. Processed red meat consumption is tied to colorectal cancer. Obesity connects to more than a dozen distinct cancer types. Unprotected UV exposure remains a major driver of skin cancer. So ask yourself this: if longevity and detection explain so much of what we're seeing today, what does that change about how you think of cancer as a modern disease? It's not new. We just finally have the tools to see it clearly. Here's why understanding cancer's ancient history actually matters right now. If this disease has existed for millions of years, it means cancer is woven directly into the fabric of complex life itself. And that ancient perspective is already reshaping modern research. Take elephants. Despite having far more cells than humans, and therefore far more opportunities for mutation, elephants develop cancer at surprisingly low rates. Scientists discovered they carry extra copies of a tumor-suppressing gene called TP53. Researchers are now studying that gene closely, hoping it could inform future human cancer treatments. The fossil record itself keeps proving useful, too. By comparing ancient bone tumors to modern cases, scientists can track how certain cancers evolve, and which conditions seem to trigger them across vastly different environments and eras. Cancer was never just a medical problem. It's an evolutionary puzzle stretching back millions of years, one that connects a South African footbone to an Egyptian mummy, to a Greek physician naming it after a crab, to the elephant's hidden genetic defense, to you, watching this video tonight, a 1.7 million-year-old bone, a tumor. A creature that lived before language, before fire, before civilization itself. Cancer was already there, waiting, and for the first time in that long, brutal history, we finally have the tools to fight back. If this changed how you see one of humanity's old